The National Fire Protection Association, or NFPA, provides an official PDF version of the National Electrical Code, or NEC, designed for personal digital assistants, or PDAs. This allows convenient access to NEC information while in the field. You can find this PDF at the NFPA website. Several third-party applications are also available offering NEC reference information for PDA, providing quick and easy access to NEC codes and regulations. One such application is the NEC Code Reference, available in app stores. The NEC Handbook is available for Android devices. Franklin Company offers a mobile NEC tool called the NEC Code Genie, providing access to the full text of the NEC and a searchable database of code interpretations. The NEC Code Genie can be found on the Franklin Tools website. Alternative methods include printing out relevant sections of the NEC to carry in the field. Another option is to use bookmarks or sticky notes to quickly locate specific sections in a physical copy of the NEC. Finally, a document, such as an Excel or Word file, can be created containing commonly referenced NEC codes and stored on a PDA for easy access. Some sections of the NEC that might be useful to include are Article 210 for branch circuits, which covers the requirements for branch circuits, including the types of conductors, overcurrent protection, and grounding. Article 215 covers feeders, which are the conductors that supply power from the service equipment to the branch circuits. Article 220 covers branch circuit, feeder, and service calculations, which are used to determine the correct size of conductors and overcurrent protection for electrical systems. Article 230 covers services, which are the conductors and equipment that supply power from the utility to the building. Article 250 covers grounding and bonding, which are essential for electrical safety. Article 300 covers wiring methods, which are the different ways that electrical conductors can be installed. Article 310 covers conductors for general wiring, which provides information on the types of conductors that can be used in different applications. Article 400 covers flexible cords and cables, which are used for portable appliances and equipment. Article 430 covers motors, motor circuits, and controllers, which provides requirements for the installation and protection of motors. Article 440 covers air conditioning and refrigeration equipment, which has specific requirements for these types of equipment. Article 450 covers transformers, which are used to step up or step down voltage levels. Article 500 through 516 cover hazardous locations, which are areas where flammable gases, vapors, or dust may be present. Article 517 covers healthcare facilities, which have specific requirements for electrical systems in hospitals and other healthcare settings. Article 520 covers theaters, audience areas, and similar locations, which have requirements for lighting, sound, and other electrical equipment. Article 547 covers agricultural buildings, which have requirements for electrical systems in barns and other agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks, which have specific requirements for these types of dwellings. Article 551 covers recreational vehicles and recreational vehicle parks, which have requirements for electrical systems in recreational vehicles and parks. Article 600 covers electric signs and outline lighting, which have requirements for the installation and wiring of signs. Article 625 covers electric vehicle charging systems, which have requirements for the installation of charging stations. Article 680 covers swimming pools, fountains, and similar installations, which have specific requirements for electrical safety around water. Article 690 covers solar photovoltaic, or PV, systems, which have requirements for the installation of solar panels and related equipment. Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in a raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius. Table 250.122 provides the minimum size equipment grounding conductors for grounding raceway and equipment. Table 430.248 provides full load currents in amps, alternating current, single-phase motors. Table 430.250 provides full load current in amps, three-phase alternating current motors. When using the NEC, it's crucial to understand how to navigate and interpret its content effectively. Firstly, familiarize yourself with the NEC structure. The NEC is organized into chapters, articles, parts, and sections. Chapters cover broad subjects, articles delve into specific topics, parts provide more detailed requirements within an article, and sections offer individual rules or specifications. Secondly, use the index. The index is your roadmap to finding specific information within the NEC. Look up keywords related to your topic to locate relevant sections. Thirdly, pay attention to definitions. Article 100 contains definitions of terms used throughout the NEC. Understanding these definitions is essential for accurate interpretation. Fourthly, understand mandatory rules versus permissive rules. Mandatory rules use the term shall or shall not, indicating requirements that must be followed. Permissive rules use terms like shall be permitted or shall be allowed, indicating options or exceptions. Fifthly, be aware of reference standards. The NEC often refers to other industry standards, such as those from UL, or Underwriters Laboratories, or ANSI, or the American National Standards Institute. Familiarize yourself with these standards as needed. Sixthly, use the tables and examples. The NEC includes numerous tables and examples to illustrate specific requirements. Use these resources to clarify complex rules and calculations. Seventhly, consider local amendments. Local jurisdictions may amend or supplement the NEC to address specific needs or conditions. Be sure to check for any local amendments that apply to your area. Eighthly, consult with experts. When in doubt, consult with a qualified electrical inspector, engineer, or other expert for guidance on interpreting and applying the NEC correctly. Ninthly, stay updated with the latest edition. The NEC is revised and updated every 3 years. Ensure that you are using the most current edition to comply with the latest requirements. Tenthly, practice and apply your knowledge. The more you use the NEC, the more familiar you will become with its content and organization. Practice applying the code to real-world scenarios to reinforce your understanding. It is essential to understand conductor ampacity and temperature ratings. Conductor ampacity is the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The temperature rating of a conductor is the maximum temperature that the conductor's insulation can withstand without degrading. NEC Table 310.16 provides the allowable ampacities for various conductor types based on their temperature ratings and installation conditions. When selecting conductors for an electrical installation, it is important to choose conductors with ampacities that are adequate for the load they will carry. The ampacity of a conductor must be derated if it is installed in an environment with a high ambient temperature or if it is installed in a raceway with other current-carrying conductors. The NEC provides guidance on how to derate conductor ampacities in these situations. It is also important to select conductors with temperature ratings that are suitable for the environment in which they will be installed. Conductors with higher temperature ratings can be used in hotter environments without derating their ampacity. Common conductor temperature ratings include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. Understanding voltage drop is crucial for efficient and safe electrical installations. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance, which is the opposition to the flow of alternating current, or AC. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of electrical systems, and even create safety hazards. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals current in amps multiplied by length in feet multiplied by impedance in ohms per foot. The impedance of a conductor depends on its size, material, and temperature. The NEC provides tables of conductor impedance values to assist in voltage drop calculations. To minimize voltage drop, you can increase the size of the conductors, reduce the length of the conductors, or use conductors with lower impedance. Understanding overcurrent protection is essential for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. An overload occurs when the current in a circuit exceeds its rated ampacity, while a short circuit occurs when there is a low resistance path between two conductors. Overcurrent protection devices interrupt the flow of current when an overload or short circuit occurs, preventing damage to equipment and reducing the risk of electrical shock or fire. The NEC requires that overcurrent protection devices be selected and installed in accordance with specific requirements. The size of the overcurrent protection device must be matched to the ampacity of the circuit conductors. Overcurrent protection devices must also be located at the point where the conductors receive their supply. Grounding and bonding are critical for electrical safety. Grounding is the process of connecting electrical equipment and systems to the earth, while bonding is the process of connecting non-current carrying metal parts of electrical equipment together to create a low impedance path for fault current. Grounding and bonding help to protect people from electrical shock by providing a path for fault current to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. The NEC requires that all electrical equipment and systems be properly grounded and bonded. Grounding electrodes, such as ground rods and ground plates, must be installed in accordance with specific requirements. Bonding jumpers must be used to connect non-current carrying metal parts of electrical equipment together. Understanding wiring methods and materials is important for safe and reliable electrical installations. The NEC specifies the types of wiring methods and materials that can be used in different applications. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable. Each wiring method has its own advantages and disadvantages in terms of cost, ease of installation, and protection against physical damage. The NEC also specifies the types of conductors that can be used in different wiring methods. Conductors must be suitable for the voltage, current, and temperature conditions of the application. The NEC provides tables of conductor properties such as ampacity, insulation type, and temperature rating. Understanding equipment installation is crucial for safe and reliable electrical systems. The NEC provides detailed requirements for the installation of electrical equipment such as panel boards, transformers, motors, and lighting fixtures. These requirements cover topics such as mounting, wiring, grounding, and ventilation. It is important to follow the NEC requirements carefully to ensure that equipment is installed safely and correctly. Panel boards are enclosures that house overcurrent protection devices such as circuit breakers and fuses. Panel boards are used to distribute power to branch circuits throughout a building. The NEC requires that panel boards be installed in accessible locations and that they be properly grounded. Transformers are used to step up or step down voltage levels. Transformers are used in a variety of applications such as power distribution, lighting, and motor control. The NEC requires that transformers be installed in accordance with specific requirements to prevent overheating and fire hazards. Motors are used to power a wide range of equipment such as pumps, fans, and compressors. The NEC provides detailed requirements for the installation of motors, including requirements for motor circuits, overcurrent protection, and motor controllers. Lighting fixtures are used to provide illumination in buildings and other areas. The NEC provides requirements for the installation of lighting fixtures, including requirements for mounting, wiring, and grounding. Special occupancies and equipment require specific attention to detail. The NEC contains specific requirements for electrical installations in special occupancies such as healthcare facilities, hazardous locations, and swimming pools. These requirements are designed to address the unique hazards associated with these types of occupancies. Healthcare facilities have specific requirements for electrical systems to ensure patient safety. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Swimming pools have specific requirements for electrical safety to prevent electric shock hazards. The NEC also contains specific requirements for certain types of equipment, such as electric signs, elevators, and data processing equipment. These requirements are designed to ensure that the equipment is installed safely and correctly. Understanding plan review and inspections is essential for compliance. Electrical plan review is the process of reviewing electrical plans to ensure that they comply with the NEC and other applicable codes. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations are installed in accordance with the approved plans and the NEC. Plan review and inspections are important for ensuring that electrical systems are safe and reliable. Electrical permits are required for most electrical installations. The permit process helps to ensure that electrical work is performed by qualified individuals and that it complies with the NEC and other applicable codes. Electrical inspectors have the authority to approve or reject electrical installations. If an electrical installation does not comply with the NEC, the inspector will issue a correction notice requiring the contractor to correct the deficiencies. Staying current with NEC updates and revisions is crucial for electrical professionals. The NEC is revised and updated every 3 years. It is important to stay current with the latest edition of the NEC to ensure that electrical installations comply with the most up-to-date requirements. The NFPA offers a variety of resources to help electrical professionals stay current with the NEC, including training courses, publications, and online resources. Electrical professionals should also participate in continuing education courses to stay up to date on the latest changes to the NEC and other electrical codes. The grounding electrode system is an essential part of an electrical system, providing a path for fault current to return to the source and helping to protect against electrical shock. The NEC specifies the requirements for grounding electrode systems in Article 250. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrodes must be connected to the building's grounding system, which includes the grounding electrode conductor, the equipment grounding conductors, and the bonding jumpers. The grounding electrode conductor connects the grounding electrode to the neutral bus in the service equipment. Equipment grounding conductors provide a path for fault current to return to the source from electrical equipment. Bonding jumpers are used to connect non-current carrying metal parts of electrical equipment together to create a low impedance path for fault current. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. GFCIs are designed to detect ground faults, which occur when current leaks from an electrical circuit to ground. When a GFCI detects a ground fault, it quickly interrupts the flow of current, preventing electrical shock. The NEC requires GFCIs to be installed in certain locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are devices that protect against electrical fires. SIs are designed to detect arc faults, which are dangerous electrical arcs that can occur in damaged or worn wiring. When an SI detects an arc fault, it quickly interrupts the flow of current, preventing electrical fires. The NEC requires SIs to be installed in certain locations, such as bedrooms, to protect against electrical fires. Surge protective devices, or SPDs, protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electrical equipment. SPD are designed to divert voltage surges away from electrical equipment, protecting it from damage. The NEC recommends that PDA be installed in all electrical systems to protect against voltage surges caused by lightning, power outages, and other events. Overcurrent protection devices, such as fuses and circuit breakers, are essential for protecting electrical circuits from overloads and short circuits. An overload occurs when the current in a circuit exceeds its rated ampacity. A short circuit occurs when there is a low resistance path between two conductors. Overcurrent protection devices are designed to interrupt the flow of current when an overload or short circuit occurs, preventing damage to equipment and reducing the risk of electrical shock or fire. The NEC specifies the requirements for overcurrent protection devices in Article 240. Conductors are the pathways for electrical current to flow in an electrical system. The NEC specifies the requirements for conductors in Article 310. Conductors must be sized appropriately for the amount of current they will carry. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The NEC provides tables that list the ampacities of different types of conductors based on their size, insulation type, and installation conditions. Conductors must also be protected from physical damage. The NEC specifies the types of wiring methods that can be used to protect conductors from damage, such as conduit, cable trays, and raceways. Wiring methods are the ways in which electrical conductors are installed and protected. The NEC specifies the requirements for wiring methods in Chapter 3. Common wiring methods include conduit, cable, and raceways. Conduit is a rigid or flexible tube that is used to protect conductors from damage. Cable is a group of conductors that are bundled together in a protective sheath. Raceways are enclosed channels that are used to support and protect conductors. Electrical boxes are used to enclose electrical connections and devices. The NEC specifies the requirements for electrical boxes in Article 314. Electrical boxes must be sized appropriately for the number of conductors and devices they will contain. Electrical boxes must also be securely mounted and grounded.